Okay, peeps. So last time we were talking about how to properly spot sample onto the TLC plate, and then how to take the plate and put it into a TLC chamber the proper way, which included a lid and evaporating and volatilizing the mobile phase to saturate the environment that you're putting the plate into, and all of that good stuff. All right, so what I want to talk to you about in this video is something that we call the Linomat. And the Linomat is going to solve some problems in a working laboratory. You can kind of imagine the problems that we see with lab analysts spotting a TLC plate. Not everyone's spotting technique is going to be the same. If I give two people a capillary tube and I say spot the sample twice onto this spot, you know good and well that those people are going to spot the differences or spot the sample in a different way. And we needed a way to come up with a more systematic, more reproducible fashion. And this is where the Linomat comes into play. So what you're seeing over here is basically a contraption that will automatically spot the plate for you. So the piece over here to the left is going to be typically an area that you can load the plate onto, and you can tell the machine to basically take the sample that's been provided and to spot 1 or 2 drops of sample onto the point of origin. And it will do that for you. And because you're letting the machine do it, it's doing it the same way every single time, and your reproducibility goes up because of that. No longer are you relying on people's wrist technique to do it, but you're now relying on a piece of equipment to do it for you. This will allow you to spot the plate, and then typically you can take the plate, put it into the developing chamber, and allow it to develop. After it develops, you can then bring it back to this machine, and over here I'm going to call it the bread box, but this bread box will basically open up, and this thing will slide down or open up like a door, and you can take your TLC plate and you can actually put it onto the inside of this contraption and close the door back. And then up underneath this is typically a UV lamp, and that UV lamp would be cut on, and you will be able to see what the TLC plate looks like through the camera that's up here at the very top. So this is just a normal kind of run-of-the-mill camera that's okay with UV light, not a big deal at all. And you can actually take a picture or a photograph of the TLC plate as it has been developed. And you can keep that picture and store it onto a computer, print it out and put it in your laboratory notebook, do whatever you want to do with it. But that's the purpose of this setup over here to the right-hand side. So it spots the sample. You have to develop it though, just like always. Then you bring the plate back to the machine and you put it into this side, and that will fluoresce all of your spots on the sample itself. And then you can take a video feed or you can take a photograph of that as well. This thing costs quite a bit of money. And that's one of the reasons that people do not have it in a lab, especially if they do not do TLC chromatography at all or hardly any. So why would you invest thousands and thousands of dollars into an instrument like this if you're only doing TLC here and there? And of course, we do not have one in our lab because we do not do TLC that much in our lab, because TLC is not done that much when you go out and work for a laboratory or in industry. Another version of this is something called the Chroma docket system. And the Chroma docket system is made off of the same general concept that a DNA docket system would be, but it's just made for a TLC plate. So basically what happens, it's the same setup. You typically have some kind of UV light source that sits at the bottom. You open the door up, slide your plate in, close the door back so it can be in complete darkness, turn on the UV lamp. All of your spots on the lamp will show up. And then up here at the very top, you actually see some type of digital camera that's mounted onto the displayer or the magnification screen or the filtration apparatus, right? So you'll be able to take a picture, just push the button, and then you can get a photograph of your TLC plate under UV light. This is much cheaper than a Linomat is. The cost of this is just $4,800 for a simple little camera and a simple little filtration apparatus that you need. But there you go. That's one way that we can solve the problem of having these TLC plates fade into nothingness over a course of time. We don't want that to happen, right? So this allows us to take a permanent picture of what the plate looks like for our recording purposes and for what we need to document in a laboratory itself. So as far as the stationary phase goes, we've kind of already talked about this. This is just a repeat information really on this slide that you're seeing on your screen. But there's a couple of things that I want you to keep in mind of, and that's down here on the very bottom left-hand side. And these are the interactions with the stationary phase. So we often talk about polarity. Polarity is one of the reasons that things separate the way that they do in TLC, bottom line, right? We look at polarity of molecules and how it interacts with the stationary phase. But there's other things actually involved in that mix as well. It's just not simple as saying polarity, because you're also looking at solubility. So is the sample soluble in the mobile phase? Yes or no? So if it's soluble in the mobile phase, it's actually going to probably spend more time in the mobile phase and it will travel further up the plate because of that. So you got to take a look at solubility when it concerns the separation. You also have to take a look at electronegativity. This kind of goes with polarity hand in hand most of the time, but we're looking at very electronegative areas of the molecule and how those are interacting with the stationary phase and the mobile phase as well. And then kind of in the midst of all this conversation is also intermolecular forces. What intermolecular forces are at play? And you probably have talked about intermolecular forces in a general chemistry class, at least I hope that you have. And intermolecular forces would be something like hydrogen bonding. So what's going on between molecules to kind of keep them together? So are the molecules prone to stick together as a herd, or are the molecules not really attracted to each other and are okay with venturing off into the wild unknown with the stationary phase or the mobile phase? So those are four interactions that we really have to talk about when we make this TLC argument. It's not just polarity here, but it's actually all of these other things that are into the mix as well. So over to the right-hand side, you're seeing a structure of the silica yet again, and the silica, notice, is very polar. It has all these OH groups on it. It has all of these O groups on it. They're all negative areas that electrons are loaded on, and because of that polarity is very high, and those molecules will be attracted to that stationary phase if they're polar. So keep that in mind when you do make the argument, when you do talk about TLC. Basically, that's what's going on with the interactions between everything. Here's just a maybe prim and proper setup of a TLC plate into a TLC chamber. Maybe a better drawing than what I could do on the computer screen, but you're basically seeing the plate here that's grayish, and that's called the thin layer chromatography plate, or the TLC plate. You see the pencil line that's drawn down here at the bottom. Notice they put pencil, not ink. And then there's a spot in the center. That's where the spot of the mixture is going to go. The TLC plate is submerged into mobile phase, and that is the solvent down here at the bottom. And then, of course, this is my chamber, or what they're referring to as the beaker that holds everything together. Up here at the very top, they've put a lid on it, and that lid in this case is just a watch glass. That's all there is to it. So there's kind of a summary of everything that we've talked about up to this point, and maybe that picture represents it a little bit better than my horrible drawing in the previous videos.